Hey guys, welcome back to AlgoYogi. We are doing array and hashing series, and our next problem in the list is check if array is sorted and rotated. So let's go to LeetCode. There you go. So given an array nums, return true if the array was originally sorted in non-decreasing order and then rotated by some number of positions. Return true, otherwise you return false. There may be duplicate values, of course, because it's non-decreasing. That means increasing but not strictly increasing. So there could be duplicate values. All right. An array A rotated by X positions results into an array B of same length, such that BI, the BI value is basically that comes from the I plus X divided by A's length. So you're modding that rotation. Basically, you took some number and then you send it in the front of the array. So let's try to understand what the problem is asking us through an example. So let me change the view. So this is the first example that I've taken. We are given this num. We need to basically return if this nums array it was sorted and it has been rotated. So basically, this array initially it was sorted and an operation has been done on this. Basically, originally this array must have been this. So 1, 2, 3, 4, and 5. This is the original array, but then there have been 3 operations that were performed on this array, and these three elements were brought in the front, but one by one. So basically they were rotated. So that's why in the problem description they said it has been rotated by certain number of positions. So what must have happened is initially this 5 was moved here. So 5, 1, 2, 3, and 4, and then next would be 4. So you're bringing this 5 here. You brought this 5 in the front, then you bring the 4 in the front. So it becomes 4, 5, 1, 2, 3, and then finally this 3 was brought in the front, and now our array looks something like this. Now tell me, if before the rotation, if this array was sorted, then I should be able to start from some k index, in my rotated sorted array, and then I should be able to see n sorted numbers, right? Numbers. So I'm basically talking about the brute force approach right now. These indexes right here, what I'm trying to say is these indexes right here, let's say this is 0, 1, 2, 3, and 4. Now this array basically looks, if it was sorted before the rotation, then it would have 2 sorted parts. Why? Because if you see this one, this array was sorted before the rotation, so this part is sorted and this part is sorted. The reason this is happening is because this sorted part was moved in the front. That is why in my rotated sorted array, if it was sorted before the rotation, I would be able to see these 2 sorted parts. So what I'm trying to say is I do not know what is that position where the rotation happened. So that is why what I'll do is I will try. So in my brute force solution, what I will do is in this range from 0 to n minus 1, I will choose a k. In this range, and at that index I will start iterating over the array. And by the way, we will mod the length, this k value, such that we start at all the positions. For k we will start at all the positions, but the I, that value that I'm trying to find, we will rotate. So what I'm trying to say is, let's say I start at index 0, then I'm trying to find this sorted block. I see this block, this has length 3, but then I'm seeing a decreasing value. Decreasing value, so that is why I'll stop it. Okay, I'm not able to see that sorted block from this index. That's why I will start from here. Well, not again. From here, this is only sorted value. Then I will start at 1. All right. So at 1 I start, then I see 1, I see 2, and then I come back, in the beginning of the array, and then I count these all sorted values. Basically, these are increasing values. So then I see that starting at, when I started my k at 3, I was able to see 5 numbers. So I'll say at k equals to 3 index, we saw 5 integers in non-decreasing order. So that is why this will prove that this is a rotated sorted array, because starting here I should be able to see at least once n number of values if it was a sorted rotated array. So that is why this is the brute force solution, and it will be of big of n square time complexity, because for each k in the range from 0 to n, I am again rotating throughout the entire array to check if am I able to see n number of values in sorted order. So that is why this is big of n square time complexity. Now, well, space is nothing. There is no space complexity here. Now let's move on to a better approach. So instead of for each k, and then you're trying to basically find an index again in the same range leading up to the time complexity of big of n square, what I can do is I can basically turn this array into something like this. I can combine the array to itself. So what I'll do is I'm adding the array to itself. So 2 and then 3, 4, 5, 1 and 2. So don't confuse yourself. What I've done is I'm just trying to show that this right here is my one array and this right here is my another array. But the reason that I have done this is so that if you remember, these 3 values were brought here from the back of the array. Okay, they were present in the back and then they were brought to the front of the array. So I am actually appending these values next to these values, right? So instead of for each k, like in the brute force approach, I was checking again and again trying to find that index. At this position, what I can do is I will look up that position. So in this range 0 to 2n minus 1, 0 to 2n minus 1, in this range I will try to find that position, and starting there I will look for this sorted window, and if that window has the size n, and if I can find that, that means our array was basically sorted initially and then it was rotated. So that is what we will be doing. It's going to be super simple, and in the solution we wouldn't even have to append, we don't have to combine those two arrays. We can just simply go in the range 2n and then keep modding the I with the n, so it will rotate. So instead of appending this 3 right here, right after this, if I goes beyond the range, then bring it back to the front. That is what we will be doing, and this solution will be of time complexity big of 2n, or simply you can say just n. So time complexity will be 2n, and then space complexity is going to be just constant. So let's implement the solution. All right. Okay. All right. So as I said, what we are doing is we are trying to count these collected values, right? So I'll start this count with 1, because at least I'm considering one value in itself is sorted, and then let's find out the length of this nums, and this I'm trying to find if this count can go up to n, where in this range. So for I in range, I'm starting at 1, because one number is already sorted, so that I can compare that from the previous number. All right, so I will basically do 2n, and then so here if if there is a position where the current number is actually smaller than the number before, so this nums at I minus 1 is actually greater than nums at I, it should have been the other way around, right? Then I will basically say this count is gonna be equals to 1. Count is equals to 1, and then here this I, as I said, we can just mode it with n. So mode n. So if this is the case, then I'm starting to basically make my count again, so that you can start counting at this new I that we will be considering. Otherwise else count plus equals 1. And there is one more thing. If this count becomes equals to n, that means you have seen n number of sorted values, you can return true. Otherwise, in the end, you can return false. All right, so let's zoom out, and I'm gonna run this. Awesome. Let's submit. Okay. So yeah. So if this length is actually less than, if this length n is less than or equals to 2, then you can just return true right from the beginning. You don't have to enter into this bullshit. That's because two numbers, they could be same, they could not be same, but like they are already sorted, right? So that is why. All right, so now let's write down the time and space complexity. Time complexity is going to be big of n or 2n, and space complexity is going to be, although in the conceptual part it seemed like we're going to combine these two, the nums plus nums, but that was only to like understand what we were actually doing. We are basically going in this 2n range, but then to find the number you don't have to actually combine nums and nums, you can just go back again second time. All right, so this is constant. Now I might not have done great job while I was explaining in the conceptual part, because I was rushing, but I think it gives you an opportunity, or all of us, to understand what I was trying to convey. Well, okay, so these are easy problems, honestly, although this one is a little tricky, but I'm sure, I believe in you guys. So I'm gonna go back to AlgoYogi, mark this problem solved, and see you guys later in the next problem.